Alright guys, we're doing the 2012 Tabular FRQ today. The temperature of water in a tub at times T is modeled by a strictly increasing twice differentiable function W, where WT is measured in degrees Fahrenheit and T is measured in minutes. At times T equals 0, the temperature of the water is 55 degrees Fahrenheit, which is our initial condition. The water is heated for 30 minutes, beginning at times T equals 0, where values of WT at selected times T for the first 20 minutes are given in the table above. So in part A, we have to use the data in the table to estimate W prime 12, show the computations that lead to your answer. Using correct units, interpret the meaning of your answer in the context of this problem. So I have gone to do the work beforehand to make this easier. So to do W prime of 12, I have to look at the table of values and which numbers would 12 be in the middle of, which would be 9 and 15. In this case, I used y2 minus y1 over x2 minus x1 in order to find the slope of W12. So approximately, it would be 67.9 minus 61.8 over 15 over minus 9, which equals 6.1 over 6 minutes. And the answer would be 1.017. The water temperature is increasing at a rate of approximately 1.107 degrees Fahrenheit per minute at times T equals 12 minutes. In problem B, we use the data in the table to evaluate the integral from 0 to 20 W prime of T dt. Using correct units, interpret the meaning of integral 0 to 20 W prime T dt in the context of this problem. So the integral from 0 to 20 W prime of T dt would equal W20 minus W0, which according to the table of values is 71.0 minus 55.0, which would equal to 16 degrees Fahrenheit. The water has warmed by 16 degrees Fahrenheit over the interval from T equals 0 to T equals 20 minutes. For part C, for 0 is less than or equal to T, for T equals less than or equal to 20, the average temperature of the water in the tub is 1 over 20 integral 0 to 20 WT dt. Use the left Riemann sum with 4 subintervals indicated by the data in the table to approximate 1 over 20 integral 0 to 20 WT dt. Does this approximation overestimate or underestimate the average temperature of the water over these 20 minutes? Explain your reasoning. To make things easier for you guys in doing the Riemann sum, I created a special illustration that will help you guys out. So as you guys can see here, I did a rectangle with 4 subintervals as the question states. So the trick to this is always subtracting the top numbers by each other, multiplying it with the bottom because it's a left Riemann sum. So in this case, it'd be 4 minus 0, which would be 4, and the bottom number is 55. In this case, it's 9 minus 4, which is 5, and then it would be this number over here. And it continues going on, as you guys can see. So as seen in the work, you will see that I am using the formula given by them. So I am going to keep the 1/20th in the front, as you guys can see here. And I did the work that I showed you guys in the table, which came out to resulting at 60.79. The approximate is an underestimate because the left Riemann sum is used and the function is strictly increasing. Lastly, D asks for 20 equals less than or equal to T, where T is less than or equals to 25. The function W that models the water temperature has first derivative given by W prime of T equals 0.4 square root of T cosine 0.06 T. Based on the model, what is the temperature of the water at times equals 25? So with the information given, we do not know what W25 is, so I will use the information they have given me. So I have the equation they gave me, and I know that the integral would be from 0 to 25 as seen right here. So I would just make that equal to this. Once I have that, I can now solve for W25 as seen down here. So W25 equals W20 plus integral from 20 to 25 w prime of t dt. I did this because I subtracted the 25 to this side and added this on this side to isolate w of 25. So once I have done that, I know that according to the table given, W20 is 71. And once I input this into the calculator, this would give me the area under the curve, which would equal to 2.043154699. Therefore, W25 equals 73.043 degrees Fahrenheit. And this is the 2012 Tabular FRQ. These +1 would be the number of answers you would get correct if you actually took this practice test. So in this test, we would have gotten a complete 9.